So in your journal, I also gave you this sheet in your graphic. It should be in your glossary. So this is a good way to figure out what methods you should use to solve quadratic formula. Not quadratic formula, to solve a quadratic in general. So out of all of the methods that we learned over the course of this unit, this is kind of how you can figure out, okay, what's the best way to solve this. Now, on your test, I'm most likely going to tell you which method to use. All right. But let's say that I didn't. As long as it fits certain parameters, you can pick whatever method makes the most sense to use. So, for example, you first look at what form your equation's in. So, if it's in vertex form, so you know a times x minus h squared plus k, or if it's in standard form, ax squared plus bx plus c. All right. If it's yes to vertex form, you can solve by taking square roots, which we learned yesterday. All right. If it's not, and it's in standard form, you first look to see if your equation is missing a linear term, meaning it's missing that bx value. If that's yes, you solve by taking a square root. No, you look to see if it's factorable. So the way you can tell if it's factorable, all right, you can always take the discriminant and see if you get two solutions that are rational. So if you get rational solutions from the discriminant, so your discriminant's a perfect square and it's not negative, then it's definitely factorable. So that's a way you can do a quick check to see if it's even worth your time to try factoring. So if it is factorable, you solve by factoring. Now, if your a value is equal to 1 and your b value is even, solve by completing the square. And if you answer no to all of those questions, you solve with a quadratic formula. All right. So this is just kind of a good little graphic organizer to try to figure out like which method would make the most sense to use. All right. Now, again, on your test, I will actually tell you what method to use for the most part, but this graphic organizer is also in your glossary of your journal. All right. So I did already give it to you, but it's in the glossary of your journal. So let's actually look into the notes. So based off of what I just said, let's look and see how we would solve these equations. So if we look at each one of these examples, we're not going to actually solve them. I just want to know what would be the best method to solve them. So in other words, how would we solve these solutions? So I'm just asking for the best method. All right. So for the first one, what do you think? Like if you saw that, what would be your gut instinct? So of all the methods that we've used, factoring, completing the square, solving by taking a square root, all right, which would make the most sense to do for this one? You could. The a value is 1, but there's actually an easier way. Is that factorable? So could I find factors of 24 that add to -5? Yes. So you could factor, and since the a value is also 1, you could also complete the square. Now, if I were you, I would factor, because that's a little bit easier than completing the square. But again, multiple ways to skin a duck. You can do it however you want. What about 3? What do you think would be the best way? Square root. So that one, you take a square root. It's already in vertex form, so we can just take a square root. What about 2? What do you guys think? Be what? So you can solve it by taking a square root. That's probably the easiest way. But you can also solve by factoring. Because if we move the 9 over to the other side, we would end up having a difference of squares. But again, I would say for this one, take a square root. Just know that you have options. What about this one? First off, is that factorable? No. There's no way that you can get factors of 1 to add up to 6. All right? So what's really the only way we could solve this one? Completing the square. Now, all four of these quadratics we can solve with one method, the same method, and that is the quadratic formula. All right. So, quadratic formula, and I'll tell you what that is in just a second. But with the quadratic formula, that can be used to solve any quadratic. So a quadratic formula can solve any quadratic, whether it's factorable, non-factorable, the a value is 1, the a value is not 1, it's missing a bx value, it's not missing a bx value, whatever. It can solve any quadratic. That's always your go-to. So if you don't know what method to use, you can always default to quadratic formula. It will always solve it. All right. Now, is it necessarily the easiest way to solve a quadratic given its type? No. If you could factor, I would definitely factor before using quadratic formula. All right. But like I said, that's always a way that you can get an answer, but you just have to remember the formula. Now, so for these, we're going to list whether factoring or getting roots could be used to solve. And so remember, the way that you can do it is if you take the discriminant, if the discriminant is real and rational, so if it's real and rational, that means we can factor. So how do I know that my discriminant is going to be real? What are the two conditions that make our discriminant real? So think back to what we talked about, not yesterday, but the day before, with the discriminant formula. What type of discriminant tells us if our solutions are going to be real? So there's two conditions that can do that. Come on, guys, look back at your notes if you don't remember. 4.6. It's not necessarily. If it's positive, it's real.
Negative is not real.
Right, negative, it's imaginary. And 0 is also real. You just have 1 instead of 2. So, real for discriminant is a positive discriminant or discriminants equal to 0. And what's rational? How do we know if it's rational? So how do we know if it's rational? Based off the discriminant. It's a perfect square. So if it's a perfect square and it's one of these two answers, because remember, if it's 0, it's automatically a perfect square. But if it's just positive, it's a perfect square. All right. So let's look at this. So first off, we're going to identify A, B, and C. So what's my A value? It's 1. Remember, you only want numbers. If my pen will write. So there's an unspoken 1 here. So A is 1. B is what? Not just 5. Negative 5. Make sure you keep the sign. What's C? Negative 24. So here's my discriminant formula. B squared minus 4AC. So I'm going to plug into that formula. So I have negative 5 squared minus 4 times 1, which is A, times negative 24, which is C. What's negative 5 squared? Positive 25. Negative 4 times 1 is negative 4. What's negative 4 times negative 24? You guys got calculators in front of you, right? It's what? Positive 96. So if I add those together, if it will write. So if I add those together, I will get 121. All right, so my discriminant is 121. So first off, will our solutions be real? Yes or no, based off the discriminant. Will our solutions be real? Yes. How many? 2. So we have 2 real. Now, are they rational or irrational? Rational, because 121 is a what? Perfect square. So we have 2 real rational. Thus, that function is factorable. So if you have rational answers and they're real, which those go hand in hand, they're factorable. So again, that's a quick way that you can check to see if factoring is even worth your time. All right? Because whenever you solve by factoring, you're always going to get rational answers. All right, let's look at this one. So x squared plus 2x minus 20. All right, we're going to look at this one specifically, but if you look, it's the same as the one that we had at the top. They just converted to standard form. So what's my A?
1.
B? C? Negative 20. So I'm going to put it in my discriminant formula. So I have 2 squared minus 4 times 1 times negative 20. So what's 2 squared?
4.
4. Negative 4 times 1 is negative 4 times negative 20. So it's negative 4 times negative 20. Not negative, positive 80. So my discriminant is 84. So what type of solutions would I have? That's my discriminant. So 2 real. Now, will they be rational or irrational? Irrational. Why? It's not a perfect square. So would this be one that we can factor or not? We could not factor it because we'll get irrational solutions. So it's not factorable. Does everyone understand how you do that? How you can tell if it's worth your time or not? All right, take a minute, try those last 2 on your own. So find the discriminant and tell me whether it's worth your time to factor or not. So you're checking the discriminant of those 2. So make sure you're using the one that's already in standard form, or in other words, equal to 0, to get your A, B, and C. Plug it into the formula and see what type of solutions you get. Also, if you're squaring a negative, make sure, especially if you're using a calculator, you put parentheses around that negative number. Heads up. you on board. All right, if you think you have answers for both, compare with your group mates.
Abby, so what do you have? So I just made sure that that was straight to- Yeah.
All righty. So check your answers. So number 2, you should have gotten 144 as a discriminant, which means you get 2 real rational because 144 is a perfect square, so it's factorable. Number 4, you should have gotten 32 as a discriminant, so that's 2 real irrational, so not factorable. Any questions on those problems? Yeah. So again, guys, discriminant can be used as a way that you can figure out which method is worth your time using. So discriminant especially can be useful if you need to decide whether factoring is a viable method or not. All right, you guys good?
Sorry, could you stay on this screen for a little bit? Thanks.
Okay, guys, I'll give you one more minute, but I gotta move on. This is posted in Canvas.
Okay, I'm good.
All right, you guys good? Because I gotta move on. Speak now, forever hold your peace. Yep. All right, so factoring works when the discriminant is either positive plus a perfect square. So it has to be both positive and a perfect square, or 0. So if the discriminant's also 0, you should be able to factor it because 0 is a rational number and a perfect square. Now, taking a root works best when you have either positive and it's not a perfect square, you can also do it when it is positive and a perfect square. Actually, no, that's a lie. You can do it when it's 0, and that's about it. Now, otherwise, because remember we also have imaginary in there, otherwise, oh, one more thing with roots. It also works best when you have no bx value. So in other words, your bx is 0. Otherwise, we use quadratic formula. Now, you ready for it? Because here's the beast. So, quadratic formula. This is the actual formula. If you have ax squared plus bx plus c is equal to 0. So it's in standard form, it's equal to 0. Like, we do when we're factoring and we do when we're completing the square, things like that. This is the formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, that's what exactly. So, couple of things about the quadratic formula. No variables in it. That's the biggest mistake I see. No variables in that formula. Only numbers. So just like with the discriminant formula, only numbers go in it, no variables. Now, when you're looking at the formula, is there anything in there that's kind of, ringing a bell to you? Right, the b squared minus 4ac part right here. Isn't that the discriminant formula? Right. So this is actually where the discriminant comes from. Because think about it. If we have a positive and it's a perfect square, obviously the square root's going to be gone. Because if we take the square root, we'll get a nice number. If it's positive but not a perfect square, it'll be irrational because the square root will remain. We can't get rid of it. If it was 0, same thing. We can get rid of the square root. But if it was negative under that radical, what would we have to do? So if I had a negative number under that radical, what would we end up having to do? How do we take care of negatives under radicals? We know it's too imaginary, so how do I take care of it? Take out the I. So that's why if you have a negative number for the discriminant, it's too imaginary. All right? Now, there are ways to remember the quadratic formula. There is a song. Lord help, there is a song. There's actually a couple. But if you want me to sing it, I will. Oh, Lord. Okay. So I have a couple of versions. So I have one to Pop Goes the Weasel. I have one to Are You Sleeping? And I also have one to the chorus of Don't Stop Believing. Which one do you want to hear?
Don't stop believing.
Yeah. Okay, fine. Okay, you ready? Okay. No judgment. Negative b plus or minus the square root of b squared minus 4ac all over 2a equals x. There you go. So yeah, that is a way you can remember it. All right.
You gotta sing it again.
You want to hear the other ones? Okay. So the one to Pop Goes the Weasel goes like this. First, you start with negative b plus or minus the square root of b squared minus 4ac all over 2a. That's that one. It helps when your mother's a chorus teacher. Like, I kind of grew up with it. Anyway, and then the other one, do you guys want to hear the other one? Are you sleeping? So this one's kind of like a call response. So when I say it and then I point at you guys say, repeat it back to me. Okay. All right. Negative b plus or minus square root b squared minus 4ac all over 2a. There you go. All right. So that's the other way you can do it. So that's just ways you can remember it. All right. Just remember Miss Murphy singing Don't Stop Believing with it. Anyway, but you do need to memorize this formula because I can guarantee you it will show up back up in Math 3. But at that point, you're expected to know it. We don't go over it. All right. So you got to make sure that you know this formula. Now, let's actually look at how we solve. So if we look at this example, all right, This was that fourth example on the previous page. X squared minus 6x plus 1 equals 0. So they did two ways. They found the discriminant, which, by the way, what would that say about our discriminant? So it's positive, and is it a perfect square? No. So what type of solutions are we going to have? Two real, irrational. Which we can also confirm if we look at the graph. So it crosses twice, so it means it's real. All right. But if you look at what the x-intercepts actually are, they're funky decimals. Now this actually comes from Desmos. Desmos rounds them for you. So here's the thing. I don't want rounded answers. Nowhere on your Unit 4 test will there be rounded answers. So you got to make sure you know that. So again, rational versus irrational. Rational. Your discriminant is a perfect square. And positive. Irrational. Your discriminant is not a perfect square, but it is still positive. And also remember, another way you can get rational is if your D is equal to 0. So your discriminant is equal to 0. That also will give you rational. At no point, if you have your discriminant equal to 0, will you get an irrational number. You will always get rational. All right. So we're going to skip the next one, but we're going to actually look at the quadratic formula. So the easiest way to look at the quadratic formula, first off, is to do one where we can solve by factoring, because the solution should match up. So you can see that it works either way. All right. So remember, with quadratic formula, it is most helpful when you have a quadratic expression as prime, which is just a fancy way of saying not factorable. All right. Now, this first one is in fact factorable. All right. So if I wanted to solve this by factoring, how would I? So this is a review. What's my first step? We're solving by factoring. So what we did for like 3 days in a row. Nope. That's completing the square. We're solving by factoring. So you guys remember T method, reverse box, that stuff? Big X. Ring a bell. So I'm going to start with big X because we're factoring. What goes on top? Nope. You're right. You're right. It's negative 12x squared, because remember, you do a times c. And you throw the x squared on there. So we do a times c. What goes on the bottom? 11x, because that's my b value. So your b value goes on the bottom. Starting to ring bells? Yes. All right. Now, remember, your two factors are going to have x's. Now, if you're multiplying to a negative number but adding to a positive, so we have to multiply to the top, add to the bottom. That means one of your signs is going to be what? Negative. So, what are factors of 12 that will add to 11? 1 and 12. Now, since the 11's positive, which one has to be the negative? 1. So we have negative 1x and 12x. All right, which method do you want me to do? Do you want me to use T or reverse box? T? All right. So remember, we're going to take these and rewrite the 11x. So if I use T method, I'll actually just do both because they're just so you have the review. So I'm going to rewrite it as 2x squared plus 12x minus 1x minus 6. And we're going to solve by grouping. So I'm going to draw my T. And we're finding GCFs of each group. So what's the GCF of the first group? X and 2. All right, both can be divided by 2, both can be divided by x. So when I take out the 2x or divide both terms by 2x, what am I left with? X plus 6. All right, now, before we find the GCF of the second, what I tell you always have to do? Bring down the first sign. So that means our GCF is going to be negative. So then, what's the GCF of 1x and 6? 1. So our GCF is negative 1. So if we divide both these by negative 1, what am I left with? X plus 6. So we know it's correct because our two bubbles are the same. So one of my factors is guaranteed to be what? X plus 6. Cross those out. What am I left with for my second factor? 2x minus 1. Good. We're going to set it equal to 0. Now, if you're more of a reverse box person, I'll do a very quickly because you'll end up with the same thing. So remember, reverse box, you will have the first term in the top left, the last term in the bottom right, and then the two factors that we came up with can go in either spot. And then we're finding GCFs of each row and column. So what's the GCF of this first row? So what's the GCF of the first row? X. GCF of the second? 6. So plus 6. GCF of the first column? 2x. GCF of the second column? Negative 1. Remember, if the first box is a negative, you take out a negative. And we still get the exact same factors. Now, we've got the factors, so how do we solve? How do I solve by factoring?
We put them both equal to 0.
Right, we put them both equal to 0 and then solve those little mini equations separately. So I'm going to subtract 6 to both sides. X is equal to negative 6. Add 1 to both sides. And then divide by 2. X is equal to 1/2. So x is equal to the set of negative 6 and 1/2. So this should be our answer when we solve by quadratic formula. So let's see if we do get that. All right. Now, for reference, I'm going to write the quadratic formula up here. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So guys, if you know the discriminant formula, at no point should you get what's under the radical for the quadratic formula wrong. The only thing you've got to remember is the negative b plus or minus and all over 2a. Because the b squared minus 4ac we've been using for a while. All right. Now, whenever you solve with quadratic formula, I always identify a, b, and c first. So we're using the exact same problem. And you got to make sure it's equal to 0 already, which it is. If it's not, just like when we were solving with factoring, we got to move things around the equal sign. So what's my a value? 2. B?
11.
C? Negative 6. All right. Now, I'm going to put it in my formula. I'm not going to do any simplifying. I'm just going to put it in the formula. So I have x equals negative b, which is 11, plus or minus the square root of b squared, so 11 squared, minus 4 times a, which is 2, times c, which is negative 6, all over 2 times a, which is 2. Now, what I tell students is don't try to put all of that in your calculator. First off, you won't be able to because of the plus minus. break it down into pieces of what you simplify. So the first two things that I would simplify is just these two things separately. So I'm not going to add them together yet. And also go ahead and take care of the 2 times 2. So I have x equals negative 11 plus or minus the square root. What's 11 squared? 121. What's negative 4 times 2 times negative 6? So you can put that in your calculator. So negative 4 times 2 times negative 6. Positive 24. All over, what's 2 times 2? 4. Now I'm going to simplify the addition that's under the radical. So I have x equals negative 11 plus or minus the square root. What's 121 plus 24?
125.
Okay, yeah. So this shouldn't be 24. This should be 48. Yeah, negative 4 times 2, that's negative 8 times negative 6, that's positive 48. I was about to say, we're supposed to get rational answers, so we should get a perfect square under the radical. So what's 121 plus 48?
169.
169. Now that's a perfect square. All over 4. Now we're going to simplify the entire square root because the square root is a perfect square. And if it's not a perfect square, you still need to simplify the radical. So x equals negative 11 plus or minus, what's the square root of 169? 13 all over 4. Now, just like with completing the square and solving by taking a square root, what do you think my last step will be? What do we contain in that expression? It has a plus minus. So what do you think I'm going to do? Since I got rid of all the radicals and everything. Break apart the plus minus. So if I break apart the plus minus, I'm going to have negative 11 plus 13 over 4. Negative 11 minus 13 over 4. So what's negative 11 plus 13? 2 over 4. So what's 2 over 4 simplified down to? 1/2. What's negative 11 minus 13? Negative 24 over 4. What's negative 24 divided by 4? Not just 6. Negative 6. Isn't these the exact same answers that we got when we factored? Yeah. So x equals the set of negative 6 and 1/2. So like I said, quadratic formula works for any quadratic, whether it's factorable or not. Now, factoring is definitely easier. But remember, how do we know if it's whether or not something is worth trying to factor? We look at the discriminant. So if you can't tell if it's worth trying to factor or not, because factoring is 100% easier, all right, take the discriminant very quickly of the function, of the equation, and that'll tell you if it's worth it or not. Because remember, if it's worth factoring, that means the discriminant is positive or 0, and the discriminant's a perfect square. All right, that's if you know it's worth factoring or not. So let's try some more. Now, if our answer is irrational, we're going to give it in simplest radical form. All right, so all of these in here are not factorable. All right, so we have to use quadratic formula. So again, it's up here for reference. They wrote it again up here for reference. Okay, so let's do another example or two together, and then I'll let you guys try one on your own. So first off, What's my very first step that I have to do? Just go ahead and state what A, B, and C is. Now, do you necessarily have to do this step every time? Probably not. But the reason I do this is because then I know for a fact, okay, this number's B, I have to put this number here. All right. It's just kind of an assurance that you don't mess up where numbers go. All right. So, walk me through it. X equals what? What comes first? -5, because that's negative B. Then, plus or minus someone else? Not yet. Square root. Then 5 squared. Then what? -4. Then what comes next? Times 3. Then times 2. Then all over what? 2 what? Times 3. All right. So again, I've done no simplifying. I just put it in the formula. All right. So I want to start by simplifying these parts individually. All right. So x equals -5 plus or minus the square root. What's -5? No, sorry. What's 5 squared? 25. What's -4 times 3 times 2? -24. Good. All over, what's 2 times 3? 6. So guys, I'm doing these steps and I recommend that you don't shortcut this because trust me, if you try putting all of this in your calculator, I can guarantee if you don't put parentheses correctly in the right spots, you'll get the wrong number. So my recommendation, separate the square and the multiplication parts and then combine them. All right. So x equals -5 plus or minus. What is 25 minus 24? 1 all over 6. Now we can simplify the perfect square because 1 is a perfect square. So x equals -5 plus or minus what? What's the square root of 1? 1 all over 6. So our answers are going to be rational because the square root's gone. All right. So how do I get it? So -5 plus 1 over 6 and -5 minus 1 over 6. So what's -5 plus 1? -4 over 6, which simplifies down to what? -2 over 3. What's -5 minus 1? -6 over 6. So that gives me what? Not 1, but -1. Make sure you mind your negatives. So x equals the set of -1 and -2/3. So that one actually was factorable because we got rational answers. All right. Let's try another one. So let's look at B. So B is definitely not factorable because there's no way that we're going to get factors of 13, which there's only one set of factors anyway, that'll add to -8. 1 and 13, no matter how you slice it, will never add or subtract to -8. So we got to use the formula. So what's my first step? A, B, C. All right, what's my A? B? C. Good. So now we're going to put in the formula. Now, be careful with this. So x equals negative times -8. If your b value is negative, you got to multiply a negative to it. All right, because the negative is in the formula. All right. Plus or minus the square root of what? -8, what? Squared. Then times. Shh. 4 times what? Times. All over what? 2 times 1. So now we got something extra to simplify, which is the negative times the negative. So we're going to simplify all of these pieces separately. So what's a negative times -8? Positive 8. Plus or minus the square root. What's -8 squared? Positive 64. What's -4 times 1 times 13? -52. The negative doesn't cancel out. All over, what's 2 times 1? 2. So, x is equal 8 plus or minus the square root of what's 64 minus 52? 12. All over 2. Now, we know 12 is not a perfect square. So this is going to be an irrational answer. However, I want it to be the exact answer. So we can, however, simplify this radical, right? Does 12 contain a perfect square factor? Yes. What is it? Nope. 4. So 4 times what? 3. So I have x equals 8 plus or minus the square root of 4 times the square root of 3 all over 2. So I could still simplify right here. So what's the square root of 4? 2. So x is equal to 8 plus or minus 2 square root 3 over 2. Now, we don't need to break apart the plus or minus because it's irrational. We can leave it as is. But there's one more place I can simplify. Where do you think that is? The 2's and the 8. So if the 3 numbers that are not under the radical can be divided by the same number, do it. All right, so make sure those 3 numbers, it has to be all 3 numbers, not just 1 or 2 of them, all 3. So if all 3 of those numbers that are not under a radical can be divisible by another number, then simplify it. So all these numbers can be divisible by what number? So 8, 2, and 2 can all be divided by what? 2. So if I divide 8 by 2, I have 4. Plus or minus 2 divided by 2 is what? 1. Still got the square root of 3 all over. What's 2 divided by 2? 1. If I want to clean it up a little bit, x is equal 4 plus or minus the square root of 3. And since dividing by 1 is just whatever the numerator is, we can leave it like that. So I'm totally fine if you leave your answer like this. But just note that technically it is 2 different answers. You have 4 plus the square root of 3 and 4 minus the square root of 3. All right, there's still 2 different answers, but I don't mind if you leave it with the plus or minus intact to shorthand it. You just need to know that it is 2 different answers. All right, I want you guys to try letter C on your own. So I'll leave up these 2 problems as references, but I want you to try letter C on your own. So try letter C on your own. So start by identifying your A, B, and C. Put it into the formula. Don't do any simplifying yet. And then start simplifying different pieces. So I left both of these up, irrational and near rational, for reference. So be very careful when you're putting in the formula. So again, don't skip steps, because again, the quadratic formula is a pain in the butt. So don't take shortcuts, don't skip steps. If you follow the steps that I did, you'll be fine.
Yeah.
Okay, it looks like most of your exposure is simplifying the radical. Yes. Yes. Because you should have done the square root 2 first.
Okay, so that would be fine. And that would be fine. Because that should that squaring. Because then we should so that should be positive. So it's just positive. It doesn't change anything. We just have to take the negatives out. And then I think this too. Okay.
How does this look so far? I haven't fully completed it, but
So you can't take away the square root. You need to simplify that here.
oh, okay.
All right, guys. Looks like most of y'all are wrapping up. So compare answers with your roommates.
So Abby, what did you get? Okay. I haven't finished mine yet, so.
Oh, that works. So like
All right, guys. Let's go over this together. So, first off, I need to figure out A, B, and C. So what's my A? B? C. Good. So I'm going to go ahead and put it in the formula. X equals negative times negative 2 plus or minus the square root of negative 2 squared. Make sure you put that negative 2 in parentheses for you when you square. Minus 4 times 2 times negative 5. All over 2 times 2. So now I'm going to simplify all these individual parts. So I have x equals 2 plus or minus the square root. What's negative 2 squared? 4. Negative 4 times 2 is negative 8. What's negative 8 times negative 5? Positive 40. So that's where I saw some of you mess up. Some of you made that 4 negative. Some of you made that 40 negative. The negatives cancel out. All over 4. I'm going to simplify what's under the radical. So x equals 2 plus or minus the square root of 44 all over 4. 44 is not a perfect square, so we got to simplify the radical. So there is a perfect square factor in 44. What is it? What's the perfect square factor of 44? 4. So 4 and 11 are my two factors. So x is equal to 2 plus or minus the square root of 4 times the square root of 11 all over 4. So x is equal to 2 plus or minus 2 square root 11 over 4. Now, can't all three of the numbers not under the radical be divided by a number? By the same number? So can all three of those numbers be divided by the same number? Yes. So we can simplify that further. So what number am I dividing into all three? 2. So I'm dividing by 2. So x equals 2 divided by 2 is 1 plus or minus 1 square root 11 all over 4 divided by 2 is 2. If I want to clean it up just a little bit, x is equal to 1 plus or minus the square root of 11 over 2. We leave the fraction bar. Now, at the very least, if you got to this, I'm happy. Usually that last step is what trips people up. But I still want you to simplify that. Just remember, if all three numbers that's not under the radical can be divided by the same number, do it. Only if all three can be divided by that number. Put the phones up. All right, last one that we're going to do. So go to that worksheet. So, your packet did not have any imaginary solutions on it. So, I supplemented with a couple of problems. So, we're going to do number 2 together. So, we already have one side equal to 0. So, I'm going to list my A, B, and C. What's my A? What's my A? 9. B? 42. C? 50. All right. I'm going to put it in the quadratic formula. So I have negative 42 plus or minus the square root of 42 squared minus 4 times 9 times 50 all over 2 times 9. So bigger numbers. So really got to be careful with this. So I'm going to simplify the 42 squared. I'm going to simplify the negative 4 times 9 times 50. And I'm going to simplify the 2 times 9. So I have x equals negative 42 plus or minus. What's 42 squared? You guys got a calculator, use it. So what's 42 squared?
1764.
1764. Now, what's negative 4? Don't forget the negative. Negative 4 times 9 times 50. Negative 1800. All over 2 times 9, which is 18. Now I'm going to simplify what's under the radical. So I have x equals negative 42 plus or minus, what's 1764 minus 1800? I think it's negative 32, but correct me if I'm wrong. 36. Okay, I was close. So negative 36 all over 18. Now, we have a negative under a radical, so what's my next move? If we have a negative under a radical, what's my next move? What did I tell you you do every time you see a negative underneath a radical? Nope. So it's being negative, meaning you want to fight it, and you're going to start by doing what? You're going to take its I out. So I'm going to take out the I, and I'm left with a square root of 36. You cannot forget about I. If you have a negative under the radical, you're pulling an I out. All over 18. So x equals negative 42 plus or minus, what's the square root of 36? 6. So 6i all over 18. Now, can't all three of these numbers be divided by the same number? Yes. What number is that? 3, go bigger. 6. All right, now if you did it by 3, that's fine. You just have to simplify it again. So, negative 42 divided by 6 is negative 7. Plus or minus 6 divided by 6 is 6. So we just leave the I. All over 18 divided by 6 is 3. So negative 7 plus or minus I over 3. So that's where we have two imaginary solutions. Because remember, if I break this apart, that's negative 7 plus I over 3. Negative 7 minus I over 3. Either one of those works. All right, any questions? Okay, so that's it for quadratic formula. You do have a new delta math that's on this stuff. Now, again, guys, while you're doing this, okay, So don't pack up yet. Listen, while you're doing this, look through these examples and do every step that I did individually. All right? Don't skip steps, because if you skip steps, I can guarantee you'll mess up somewhere. All right? So be careful. All right? Be very, very careful. And by the way, if you do this delta math in under an hour, I don't believe you.